Hello, this is Ms. Clausing. Okay, let's finish up this review for the test. Okay, so we're dividing. So before we can divide two rational expressions, I need to turn it into a multiplication problem. So I'm going to do that first. To do that, I flip the second fraction, or multiply by the reciprocal is what it's really called. So I have x squared over x plus 3. The first fraction doesn't change. But then to change it to multiplication, I flip the second fraction. So I have x squared plus 6x plus 9 over x squared minus 3x. Okay? Then I need to factor anything I can factor so that I can cancel out anything I can cancel out. So let's start down here in this denominator, in the second denominator. I have a GCF here that I can pull out of x, so I'm going to do that. So I have x times x minus 3 is what's left over. Alright, then I have, let's go up to this quadratic in the numerator here. I can factor this as well. I'm looking for two numbers that multiply together to give me a 9 and add up to a 6. So that would be a 3 and a 3, add up to a 6, multiply to give me 9. So my factors are x plus 3 and x plus 3. This bottom numerator here, it's not a quadratic, I can't factor it. The numerator in the first fraction, though, I could rewrite this because it have two x's. So I could break this apart and write it as x times x if that makes it easier for you to see what you really have going on there. Alright, so let's cancel out whatever is matching in the numerator and denominator. So I have an x plus 3 here. That will cancel out one of the x plus 3's in the numerator. I also have an x here, which will cancel out one of the x's in the numerator. And that's it. So now I'm going to write what's left over. I have this x still, so I have an x, and I still have an x plus 3 over here in the numerator. That's not canceled out, so I need to write that down. And then in the denominator, the only thing I have left is this x minus 3, so that's what's left there. And I don't see an answer that matches, but I don't have anything else to cancel out. So I'm going to go ahead and get rid of these parentheses and see if then I have an answer that matches. So to get rid of the parentheses, I need to distribute this x in. So x times x gives me an x squared. X times a 3 gives me a plus 3x, all over x minus 3. And now, sure enough, I can see my answer very clearly is F. All right, 14. Whenever it says which expression is equal to, all that means is you're basically going to simplify the expression and see what it equals. So we just need to simplify this. First thing I'm going to do is I'm going to factor or pull out any GCFs I can from the numerator. Well, from the numerator, I have a y, they both have at least two y's. So I can pull out a y squared out of the numerator, which will leave me with 4y cubed minus a 3y, or just 3, sorry, because that y squared came out front, divided by 5y squared. Now I see that I have a y squared in the numerator and the denominator that are multiplied, so they can cancel with each other. And that's it. So what's left over is a 4y cubed minus 3 over 5, and that's it. Now, I look at this and I'm like, all right, I did everything I need to do, but I still don't see an answer that matches exactly. Well, remember, I can rewrite this as 4/5 y cubed minus 3 over 5. Okay, which now I see that matches D. So while these two, this answer here and this answer down here, are saying the same thing, I sometimes have to kind of adjust it just so that I can pick the right answer. Okay. Another division problem. Let's skip this one actually. Yeah, we're gonna skip that one. If you want to work this one out, I will tell you the answer is G, which is 2/3. But I'm not gonna solve it out on the video. Alright. Again, this is a very similar problem to the last one. The answer also is coincidentally 2/3, but I'm not going to solve that one out either. 17. Alright, so I'm just trying to simplify here. To be able to simplify, I need to factor my numerator and factor my denominator so that I can cancel out any factors that match. So I'm going to start with my numerator. I have x squared minus 25. Well, I know that's a difference of squares. So that's going to give me an x plus 5 and an x minus 5, because the square root of 25 gave me the two 5s. Difference of squares gives you one plus and one minus sign. Now, this goes way back to the beginning, but this denominator is a sum of cubes. So remember, we do sum of cubes when we factor. Set up one big parenthesis and one small parenthesis. The cube root of each term goes into the small parenthesis. So I have x cubed, the cube root of that is x. 125, the cube root of that is 5. And I will take care of the signs at the end using SOAP. Remember SOAP? So the big parenthesis, remember I have the first term here. We're going to end up with 3 terms. Okay? The first term is the first term in my small squared, so it's x squared. The middle term are my first 2 terms in my terms in my small multiplied, so it's 5 times x. And my last term is the second term in my small squared, so that's 5 squared, which gives me a 25. So remember, this came from the 5 squared, this came from the 5 times the x, and this first term came from the x being squared. Okay? That's where those are coming from. It all came from here. Alright, now remember we use SOAP to fill in our signs. We have same, opposite, always positive. Same as the original was a positive, opposite is a negative, always positives. Always positive. Alright. So then I need to see if I have any factors that cancel, and sure enough I do. I have an x plus 5 here and an x plus 5 here, they cancel out. Now, I also need to check to see if I can factor this big parenthesis here. I have x squared minus 5x plus 25. So I need to look, are there any 2 numbers that multiply together to give me 25 and add up to a negative 5? And I would find that, nope, there are not. It's not factorable, so I don't need to factor that. So what I'm left with is, in my denominator, I have this x minus 5x plus 25, which came from this right here. And I'm also left over my numerator with this x minus 5 right there. Okay, so my answer is G. Alright. Alright, so let's do some subtraction. So to be able to subtract fractions, remember my denominator has to be the same. So I need to first see how I can get my denominator to be the same, but before I can do that, I need to factor any denominator that can be factored. So this first fraction, the denominator, can be factored by difference of squares. We have an x and an x, and square root of 9 gives me a 3 and a 3, and difference of squares always gives me 1 plus and 1 minus sign. Alright, so then I need to look and see what is this second fraction or second denominator missing that the first denominator has. They both have an x plus 3, but the second denominator is missing an x minus 3. So I'm going to multiply this second fraction by x minus 3 over x minus 3. Okay. Now I need to distribute. I have x times x gives me an x squared, and x times a negative 3 gives me a negative 3x. All over my new denominator of x plus 3 times x minus 3. Alright, my first fraction, I didn't change it any. I just factored the denominator, so it's not going to change. I'm just going to write it down. I have 9x over x plus 3, x minus 3. Alright, so now my denominators are the same. They match, so I can go ahead and add or subtract my numerators. So I'm going to look for like terms here. Well, we'll go ahead and write them down, and then we'll just combine like terms. So I have a 9x, and then I have this minus an x squared. And again, another minus the negative 3x minus a minus sign gives me a positive 3x. Alright, now let's combine like terms. I have a 9x and a positive 3x here, which will give me a 12x. And this negative x squared, I'm going to put it out front because just to put it into standard form. And then my denominator is x plus 3 times x minus 3. When I add and subtract, the denominator doesn't change. Alright, so I still don't see any answer choices that match exactly, but some that are kind of similar. So let's see if we can, now we need to factor our numerator and see if we can find an answer that matches. So in my numerator, I know they both have an x in common. And I also know whenever I see a negative in front of that leading term that I need to factor out or pull out a GCF of a negative. So I'm going to pull out a negative x. They both have an x in common, and I know I need to get that negative out front. So that leaves me with an x plus a 12 over x plus 3, x minus 3. Alright, so now I can see that my answer is B. Okay. Next. Okay, 19. So I need to, neither of the denominators can be factored, but I need to make them the same. So first thing I'm going to do is see if I can make one of the numbers match the other number by multiplying it by something. And I know that if I multiply 5 by 3, it will match the 15. So I'm going to multiply the second fraction by 3 over 3. I also noticed that this b, I need a b with this 5. So I'm also going to multiply the second fraction by b over b. Okay? Alright, so let's go ahead and do that. So I have 2b times 3b, which would give me a 6b squared. And then 5 times 3b gives me a 15b. I'm subtracting, so I'm going to drop down that minus sign. And I didn't do anything to change the numerator or denominator on this first fraction. I'm just going to bring it down then. Now my denominators match, so I go ahead and subtract like terms in my numerator. Well, I don't have any like terms. I have an a to the first and a b squared. So I'm just going to write them down next to each other. And I will put the largest exponent first, which you don't have to do, but that's technically standard form. And the answer actually is not like that, so we won't. But we have 7a minus a 6b squared all over 15b. And I can see now my answer is H. All right, let's see, next one. Okay, so 20. My denominator is already matched, so I don't have to change anything. I can just go ahead and just subtract like terms in the numerator. So I have the 6x minus in the middle here. So minus 2x gives me a 4x. And then I have a 7, again, minus in the middle, so minus 5. 7 minus 5 gives me a positive 2. I don't know why it's writing funky. And then I just write down my denominator, which already matched. I didn't have to do anything, so 2 times x plus 3. Now, I see that the numerator has a GCF, so I need to pull that GCF out. My GCF in the numerator, they both are divisible by 2, both terms. So 4x divided by 2 leaves me with a 2x, and 2 divided by 2 leaves me with a plus 1, all over 2 times x plus 3. All right, well, now I see that I have 2 in the numerator and denominator, so those will cancel out. And leave me with a 2x plus 1 over x plus 3, so C is my answer. Alright, whenever you see it says, what is equivalent, that just means simplify. Simplify or solve it, okay? Alright. Alright, then let's skip 21. The answer for 21 is G, but for the sake of time, I'm going to skip it. Let's go over here to let's do a few of these solving ones. Alright, so we're going to skip 22 as well, but, well, you can't skip it. I'm going to skip it. 22, the answer, though, is A. You need to show your work for credit on that. Alright, 23. What is the solution? Well, remember, we just did solving equations. And when I'm solving equations, the first step was I need to get common denominators. Well, for 23, it's pretty simple. They're already common. So then the next step is, when I'm solving equations, I can go ahead and flatten the problem. So I can get rid of those denominators. And it leaves me with a 3x squared minus 2 equals 6x minus 2. And then I just solve. So I'm just going to combine my like terms. So let's see, let's just move everything to one side to get started. So we have minus 6x minus 6x. There's no like term on the left, so I'm just going to write it in there. 3x squared minus 6x minus 2 equals a negative 2. And I see I have a quadratic, so I know I might have to do quadratic formula, which case, or factoring to solve it. So I'm going to go ahead and move everything to one side of the equation. So my 2's cancel on the right, and they actually cancel on the left as well. So on the right, it leaves me with 0, and 3x squared minus 6x. All right, so let's go ahead and factor this to find my solutions. Well, to factor it, I just need to pull out a GCF first. So I notice they both have a 3 in common, so I'm going to pull a 3 out, and they also both have an x in common. So I'm going to pull an x out, which leaves me with x minus 2 in parentheses equals 0. All right, so now I need to solve both of these. I have 3x is one of my factors, and I have x minus 2 is my other factor. Well, to solve them, I just set them equal to 0 and solve for x. Over here, I divide by 3. X equals 0 divided by 3 is just 0. And then over here, I'm going to add 2. So x equals a positive 2. All right, so I have two solutions. However, remember, when we're solving rational equations, we always have to check for extraneous solutions. So I'm going to take each of these solutions individually and plug them back into the denominators in the original problem. If I plug a 0 in here, I'm going to end up with my denominator equaling 0. Well, if it equals 0, remember, that means it's an extraneous solution. So this is not a real solution, it's an extraneous solution. Okay? So automatically J is not the answer. Let's check this 2 over here, this other solution. If I put a 2 into the denominator here, that means my denominator equals 2. 2 is fine, as long as it doesn't equal 0. I can also check this one over here. So if I put a 2 in here, my denominator equals 2, does not equal 0. So this x equals 2 is a real solution, and so G is my only answer. Okay? All right, let's do this next one. Erase this. If you need to back up, you can do that. All right, so I have, I'm trying to solve a rational equation, but before I can do that, I need to have a common denominator. Well, there's no way I can multiply anything by 15 and get it to equal 18, and there's no way I can multiply anything by 18 and get it to equal 15. So I'm going to multiply them by each other to get my common denominator. So over here, I'll multiply it by 18 over 18. And on this side, I'll multiply it by 15 over 15. Okay? So that will give me 15 times 18. I just don't have this written down. Let's see. Come on, turn on. 15 times 18 gives me 270. So my new denominator will be a 270. And the numerator on the right will be 15 times x, which gives me a 15x, and 15 times a negative 2, which gives me a negative 30. And then my equal sign. And over here, I have 18 times x, which gives me an 18x. 18 times a negative 3 gives me, let's see, that's 30 plus 24 is 54. over 18 times 15, which gives me my 270. Alright, so now I have a common denominator. I'm solving an equation so I can flatten the problem. That leaves me with 15x minus 30 equals 18x minus 54. Now I just need to combine like terms. So I'm going to move this 15x over to join this 18x. So leaves me with a negative 30 equals 18 minus 15 is 3x minus 54. Alright, let's now move this 54 over, so we're going to add 54 to both sides. That leaves me with a 24 equals a 3x, because those cancel. And then I divide both sides by 3, and that leaves me with 8 equals x. I need to check for extraneous solutions. Well, there's no variables in my denominators in the original problem. It's just 18 and a 15. So there's no way that I need to even plug this in anywhere. So my answer is J. Okay. Okay, let's do one more. Let's do 25 and then we'll move on to variation. Okay, so 25, remember, I'm solving an equation here. Before I can solve the equation, I need to have a common denominator. So I'm going to first, remember that denominator under that 1 is a 1. So I'm going to write that in so I don't miss it. Alright, so now I need to think, what do all of these need that the other denominators have? Well, how about this middle denominator? It has an x, but it needs to also have a 5. So I'm going to multiply it by 5 over 5. The first denominator, it has a 5, but it needs an x. So I'm going to multiply it by x over x. And then this last fraction here, the denominator needs both a 5 and an x. So I'm going to multiply it by 5 over x. Or 5x over 5x. Alright, so let's take care of this now. I have this first fraction. I will have 2 times x, which will leave me with a 2x, and x times 5, which will give me a 5x. It's an x. I don't know why it's doing that. Plus sign, just write it down. Middle fraction, I have 2 times 5, which gives me a 10, over 5 times x, which gives me a 5x. Equal sign. Last fraction, I have 5x times 1, which gives me a 5x, and 5x times 1, which gives me a 5x. Great, now I'm solving an equation, so I can go ahead and flatten the problem now that all my denominators match. That leaves me with a 2x plus 10 equals 5x. And I just need to combine like terms. So I'm going to move this 2x over to join my 5x. So it goes away and leaves me with 10 equals 3x. 5 minus 2x is 3x. And then I divide both sides by 3. So that will give me x equals 10 thirds, which is J. Alright. Okay, I'm not going to go through 26. You can do that one on your own. It's very similar to the ones we've just completed, but the answer is A. You need to show your work for credit. Okay, so let's go on to variation. We'll do a few variation problems. On this page, I'm not going to do all of these, but we will do some of them. I want to do, let's do number 2. Actually, I may only do number 2. Let's see. Alright, so remember variation problems. You can pull out that foldable we made. But what we're going to do is we're going to read through and we're going to underline anywhere we see a variable and we're going to put a box around any of our variation types. Remember our variation types are direct, inverse, joint, and combined. Okay, so let's just start reading this. The pressure P in a liquid varies jointly as the depth D and the density D of the liquid. Read that first sentence. I'm going to stop and write my variation equation. So I have pressure P equals, when I see jointly, I know I'm going to write down it equals K and it'll be multiplied by something. As the depth, it'll be multiplied by D, and the density, big D. Okay? If the question asks you, write the variation equation, this is where you would stop. Okay, let's continue on though. If the pressure is 200 pounds per inch squared, so as I read these, the next part, I'm going to write down the information given to me. Remember, the next sentence is going to give me the information I need to solve for K, which is my constant of variance. So the pressure is 200 pounds per inch squared, when the depth is 150 inches and the density is 1.4. Then it says find blah, blah, blah. Find something. We're going to stop there and solve for K. We now have everything we need to solve for K. They've given me P equals 200 up here. They've given me little d, depth, which equals 150 right here. And they've also given me big D, which is density of 1.4. Alright, so I'm going to plug these into this equation I set up and solve for K. So P is 200 equals K, which I'm going to find. Little d is 150, and big D is 1.4. Alright, so I'm going to solve this now. 150 times 1.4. You put that on your calculator. It gives me 210. So then I'm going to end up with K times 210 equals 200. Divide both sides by 210. Gives me 0.95. I'll write it down here. It's going to give me a constant, variance constant of 0.95. 2. We'll just round it off. Okay? Alright, so now I have my constant variance. My question could ask me to find my constant of variance, in which case I would stop right here. Okay? But this question is going to ask me to use this constant of variance to make a prediction or find something. So to do that, I'm going to put this constant of variance back into the original equation that I made, which is P equals, now I know my K, which is 0.952, little d, big D. Okay, or depth times density. Okay, so now it's going to tell me find the pressure when the density remains the same. We'll do this one blue, so the density is the same, and the depth is 80. So my density is big D. Big D remains the same. So I'm going to go back to the original problem. It said density originally was 1.4. And my depth, little d, is 80. Alright, now I just plug these in. So I have 0.952 times my little d, which is 80. And big D, or density, which is 1.4. Equals the pressure, which is what I'm looking for, so that'll just stay as P. And now I just put all these in my calculator. So 0.952 times 80 times 1.4 gives me a pressure equal to 106.624. Okay? So that's my answer. Alright, so that's that one. I think that's the only one I'm going to do. These other ones are very similar to your notes on variation. So if you go back to those notes on variation, the only difference are the numbers. So you can use those as a guide to do the rest of these variation problems. So that should help you. This middle one is probably, make sure you know how to do this one. It's very important. And that should help you out. So that's it. Finish that review, study for your test, and